Watch this function. I call it 3 times with 3 different lists. Same code, but somehow the third call remembers everything from the first 2.
That is not a coincidence. It is one of Python's most famous traps. I'm Mahaz, and this is episode 69 of the series. Copying, deep copying, and how Python actually stores things in memory.
Once you see why this happens, you'll never write this bug again. Forget the idea that a variable is a box holding a value. A variable is a label, a name pointing at an object somewhere in memory.
ID of an object gives you its actual memory address as a number.
Equals B does not copy anything. Both labels now point at the same object.
The is operator checks whether 2 labels point at the same object. Equals checks whether the values look the same, even in different objects.
This one distinction is the root of almost every copying bug you'll ever hit. A shallow copy makes a new outer object, but keeps the same inner objects. List.copy or the slice trick with a colon both make a shallow copy.
Copy.copy from the copy module does the same thing for almost any type.
For a flat list of numbers, a shallow copy behaves exactly like you'd expect. But nest a list inside that list, and the inner list is still shared.
Change the inner list through the copy, and the original changes too.
Shallow means one layer of protection. Nothing deeper than that. A deep copy walks the entire structure and copies every nested object too.
Copy.deepCopy, one function call, complete independence. Now the inner list is a separate object, not a shared reference.
Change the copy, and the original stays untouched, no matter how deep it's nested. The trade-off, deep copy, is slower because there's more work to do.
Shallow for flat data. Deep the moment your data has nested mutable pieces.
Remember that function from the start of the video? Here's what actually happened.
Def add underscore item of item, comma, bucket equals an empty list. That empty list is created exactly once, when the function is defined, not each call.
Every call that skips its own bucket argument shares that exact same list. The fix, default to none, then build a fresh list inside the function body.
The bucket is none, bucket equals a brand new empty list.
One of the most common bugs in real Python codebases, and you just fixed it.
If this is useful, subscribing genuinely helps more people find it. Thank you.
3 places this exact bug shows up in real projects. A cache dictionary passed as a default argument, quietly shared across every call.
A config copied with .copy, but its nested settings still linked to the original.
A class attribute defined as a list, shared by every single instance of that class.
Same root cause every time an object being shared when you expected a copy.
The fix is always the same instinct, ask whether this needs to be shallow or deep. Let's actually debug one of these the way you would in a real project. First, print ID of the original and ID of the copy. If they match, nothing was copied.
Second, check ID of a nested piece like the first inner list on both objects.
If those match too, you have a shallow copy problem, not a deeper data bug. The one-line fix, swap copy.copy for copy.deepCopy.
Print the IDs again. Every level completely different now. Fully independent.
Compare IDs, find the shared layer, deep copy it. That's the whole process.
Quick one. Before I show the answer, guess what this prints. Is 1, 2, 3. B equals A. B.append of 4. What does it look like now?
If you said 1, 2, 3, 4, you already understand the reference rule.
Second one, same setup, but B equals a .copy this time. What about a now?
Just 1, 2, 3. The copy broke the link at the outer level.
Last one, nested lists, a shallow copy, and an inner append. Trickier, but you have the tools. Here's something worth trying on your own. Build a nested dictionary with a list inside one of its values. Make a shallow copy and a deep copy side by side. Modify the nested list through each copy, and print all 3 versions. Watch which ones change together and which one stays independent.
That single exercise will make this concept permanent.
A few ideas worth keeping.
Variables are labels pointing at objects, not containers holding values.
Shallow copy protects the outer layer. Deep copy protects everything all the way down.
Mutable default arguments are built once. Never rely on them for fresh data.
When something changes in two places at once, check whether it's really the same object.
That habit alone will save you from some of Python's sneakiest bugs. That's copying and Python's memory model from the ground up.
Next time, we bring almost everything from this series together into one real deployed app. If this helped, following along for that finale would mean a lot. Thanks for watching. I'll see you in the next one.